Question 39. Find the area of the shape below. This is a trapezium, if you know, and formula for the area of a trapezium is half into open bracket a plus b h, where this can be a, that's ab, and this can be b, line e to f. This line that runs from e to f. Applying this formula, looking at this question, we see that we have our height and our a, but we don't have our b. We have to calculate our b. If ab is 12, then cd is 12. The distance from here to here is the same as the distance from here to here. This is 12 centimeters. If we have this as 12 centimeters, we also need the distance from here to here and from here to here, that's from C to E and from D to F, to complete B that runs from E to F. Note, this question is quite complex. It's not a straight one. Have no fear, we can solve it. This is a right angle triangle. Not looking at the total shape, look at this triangle. Try and notice this right angle triangle, that's from B to D to F back to B. This is a triangle and it's a right angle triangle. And same as this, we have A to C to E and back to A. It's also a right angle triangle. Although this part is indicated for the right angle, also this other part too is a right angle because this is a straight line. A straight line is 180, and if part of the angle is 90 and is divided into 2, the other part is 90. So this part is also 90. That's 180 minus 90 is 90 because this is a straight line. Once you know that, we can apply Pythagoras theorem to find this side, just noting the hypotenuse. And this side, EC, is the same length as this side, DF, because AC is 4 centimeters, BD is also 4 centimeters. It's a trapezium. This height is the same thing as this height. Therefore, this is 4 and this is 4. And with this triangle, we can find this side using Pythagoras theorem. The triangle, let's draw it out. We have the right angle, we have our A, we have our E, and we have our C. So we have this part. This is 5 centimeters and this is 4 centimeters. And since it's a right angle triangle, we can apply Pythagoras theorem to solve for line EC. We can name it X. So to find this side, we use the formula hypotenuse squared equals opposite squared plus adjacent squared. Like said in previous questions, we need to find the hypotenuse, and the hypotenuse is the side facing the angle 90 and the side facing it is 5. So we have our hypotenuse as 5 squared equals, we have 4 here, so this can be 4 squared plus our adjacent, which is x squared. This can either be adjacent or this is opposite. Whatever opposite, we'll still get the value for it, or the numeric value for it. We're looking for x. 5 squared is 25 equals 4 squared is 4 times 4, that's 16, plus x squared. We can take out this 16 has a plus. Since a negative sign is not written in front of it, it's definitely positive, so we'll take it out. So we have that 25 minus 16 equals x squared. We've taken out the plus 16, crosses the equals to sign, turns to minus 16. We have 25 minus 16, that's 9 equals x squared. Since we want our x squared on this side on our left and this on the other side, at this point we can switch them. We don't need to change the signs. We have this equals this, that's x squared equals 9. For us to find the value of x, introduce square root to both sides. As we can have it like this, square root here and square root here. So square root cancels square. For us to find x alone, square root of 9 is 3. Therefore, the value of our x is 3. Going back to our diagram, we now know EC is 3 and also DF is 3. Then B, which is E to F, will be 3 plus 12 plus 3. 3 plus 12 plus 3, that's this total line from point E to point F is 18 centimeters. That's 3 plus 12 is 15. 15 plus 3 is 18. Therefore, line EF is 18 centimeters. Let's place the same diagram here so we can have a better understanding. We now know the distance from this point to this point is 18 centimeters. We know A is 12 centimeters, B is 18 centimeters, H, which is the height, is 4 centimeters. We apply the formula for finding the area of a trapezium, which is half open bracket A plus B close bracket times H. We can also say A plus B in bracket times H over 2, whichever formula you prefer. we can apply this formula that says a plus b in bracket times h. Our a is 12, our b is 18, put it in bracket times our h, which is 4 over 2. It's best to solve what is in the bracket first, or you go for this. That's 2 into 1, 2 into 4, 2. You solve what is in the bracket first to save yourself problems. So we have 12 plus 18. 12 plus 18 is 30 times 4 over 2. At this point, we can cancel out. We can say 2 divided by 2, 1. That 2 same 2 in 4, that's 2. So we have 30 times 2. 30 times 2 is 60. So we have our answer as 60 centimeters square. The answer to question 39 is E, 60 centimeters square. Apart from using the formula for the area of a trapezium, we can also solve for the area of this trapezium in bits. We can take this as A, this as B, and this as C. That's the area of triangle A plus rectangle B plus triangle C. Add it together, you still get the same answer. And noting that this is 3, and this is 3, and this is 12. We start with the first right angle triangle, which is triangle A. The area for triangle A, which is a right angle triangle, is half base times height. So we have our base as 3, we have our height as 4. So we have it as half times our base is 3 and our height is 4. Note that we've calculated this side to be 3. Then we can apply this formula. We can choose to multiply 3 times 4, 12 over 2, or we can just say 2 into 1, 2 in 4, 2. We will still end up getting the same answer, which is 6. Or we can multiply like we've done, then say 2 divided by 2, 1, 2 in 12, 6. Area to triangle A is 6 centimeters square. Shape B is a rectangle. Area of rectangle B, that's rectangle B, is length times breadth. Looking at B, that's A, B, D to C back to A. This shape, it is a rectangle. This is 12, this is the length, and the breadth is 4. This side is 4. So we have to ask 12 times 4. 12 times 4 is 48 centimeters square. The third shape is also a triangle like A, and note it's the same thing. They both have the base of 3 and the height of 4. So we can say triangle C, that shape C, is half base times height. Half, your base is 3 times your height is 4. In this case, let's just say 2 into 1, 2 in 4 is 2. We're now left with 3 times 2, that's 6 centimeters square. We have area of triangle A as 6, area of rectangle B or shape B as 48, and area of triangle C as 6 centimeters square. Area of total shape is area of triangle A plus B plus C, which is 6 plus 48 plus 6. 6 plus 48 plus 6 gives you 60 centimeters square. That's the same answer using two different methods, whichever you prefer. There will be cases where you don't have a regular plane shape. In such cases, you can apply this formula where you find the area of shape A, area of shape B, and area of shape C, and add them all together and get your final answer.